During the late evening hours of April 3rd, 2026, a massive windstorm started making its way through the Oklahoma City area, bringing damaging winds close to 100 miles per hour and a few low-end tornadoes. In today's recap, I'll be breaking down the model's mistakes, along with a breakdown of the storm that brought the damaging winds and tornadoes across the Oklahoma City area, and the mistakes of the Storm Prediction Center's outlooks. First, I want to go ahead and break down the model, specifically the HRRR model, or the HRRR, as some people like to call it. I want to break this specific model down because this one's the one that was closest, along with another model that I don't have access to on this specific website I'll be using. But the HRRR model, as shown by 18Z's run, several smaller supercells take off in southwestern Oklahoma with a more linear mode to the north. Now, this is generally exactly what happened during the actual event. The only problem was these storms did not converge into the line, as seen here. They start to cluster up and then merge with the KLCS line developing and turn into a linear mode going into Oklahoma City. And something else I want to mention is the very, very large hail, because at least one supercell in southwestern Oklahoma produced baseball-size hail, and it was pretty much this one right here, except it was placed a little further northeast. However, the linear mode didn't stretch all the way down. It stayed only in northern Oklahoma until the late evening hours. The cold front station pretty much where it is, where the models showed it to be. Also, these extra little cells out here did not really fire off either. But we're talking about the supercell that brought the damaging winds into Oklahoma City, and that very clearly didn't show on the models here. It showed them going linear just prior to entering Oklahoma City, but obviously that wasn't entirely true, and that cold front obviously did eventually come through as well, pushing the severe risk down south and southeast. But something I wanted to take note of was the fact that the Hill-to-Sea tracks were still pretty strong going into Oklahoma City as well, showing that large hail and tornadoes would still remain an issue, but that was not on the Storm Prediction Center's list. Now, with the Storm Prediction Center's outlooks, a level 3 enhanced risk sat up in southern Iowa and northern Missouri. This is where the highest tornado chance was predicted to be. Now, obviously, there was a couple brief and weaker tornadoes up there. However, it was only like maybe a little less than a half dozen as a whole. I'm going to go back and kind of look at those tornado numbers just to 100% confirm. However, a level 2 slight risk stretched down all the way down into eastern Kansas, southwestern Missouri, and the majority of Oklahoma and northwest Texas. In this slight risk sat a 2% unhatched tornado risk, where the potential for a tornado or two was kind of suspected in case the line did kind of spin up on the front edge, and that is certainly kind of what happened. However, in the Storm Prediction Center outlook, they mentioned that it would remain mostly linear by the time it got into Oklahoma City. But they did also mention that a few supercells were likely towards the initiation. However, obviously, this was not the truth whatsoever. And I also want to go ahead and go over the damaging winds in the outlook. There was only a 15% unhatched risk for maybe 60 to 70 mile per hour wind gust. However, as the big storm started going through Oklahoma City, southern Oklahoma City, the winds were cranking 60, 70, 80, and even close to 90 to 100 miles per hour. Well out of that outlook range for sure. Okay, now let's go ahead and start with the actual event itself. First, I do want to go over this little area down here in southwestern Oklahoma and northwest Texas. This was the start of the supercells that would eventually make their way into central Oklahoma and Oklahoma City. This was actually kind of off the dry line, which was sitting off in far northwest Texas and far, far southwest Oklahoma. This was kind of the converge area of the cold front and the dry line, which created a bit more unstable air in that general area. And as you can see, they had more supercellular characteristics rather than linear, especially that one near Vernon, Texas. Um, Now, again, this was the start of what would eventually come into Oklahoma City, and going up a little bit more to the north, up here from about Wichita, Kansas, down to Enid, Oklahoma. This was more the linear storms that would continue off to the east southeast. However, it would not connect with the supercells down in southwest Oklahoma. And this is when the models kind of got pretty wrong here compared to what actually happened. What happened in the models of the linear storm kind of up north was supposed to connect with the supercells and merge with them, creating a massive line of severe thunderstorms that would eventually go into Oklahoma City with the chance of a few spin ups and damaging winds 60, 70 miles per hour. However, in the end, the cold front didn't press down up north strong enough to create more ignition down the line. So the supercells were able to continue to stay out ahead of the cold front and remain spinning, dropping large hail and, of course, later the damaging winds. Okay, and as these storms began to continue off the cold front, very noticeably, two supercells took shape. This one, which brought the tornadoes and damaging winds into southern Oklahoma City and eastern Oklahoma City, and this one in the specific radar sweep you can't see as well, but that is another supercell back there, kind of interacting with a few storms behind it. But as we continue the radar loop, you kind of see the linear mode, and then it kind of transitions into an embedded supercell, dropping baseball-size hail. And it did produce a mesocyclone that got close to producing a tornado or two. However, luckily, kind of out the cold front eventually undercut it, and the supercell further up to the north, which was organizing during this, it very quickly blew up just west of Canadian County in El Reno, and that mesocyclone quickly started to develop and would eventually become the more dominant storm in the area and the largest and strongest for the overnight hours. Okay, now something else I want to go over is notice these little cells out ahead of the main storm. Watch their orientation as the much larger storm gets closer. I noticed this started happening as the storm got closer, and just prior of entering Cleveland and Oklahoma County, that big bowl, that big kind of bow shape you see there, is when it started to ramp back up after a recycle. It underwent about roughly 3 recycles before converging into a bow echo, along with the remaining of the line, and continued off to the east. And these little cells, beginning just around the Norman area, continued up north before transitioning into a more northwest orientation going into the storm. This gave it an almost hurricane-like shape, like hurricanes with the supercell and rain bands feeding into the main core. And this is what really kind of fueled that tornado and damaging wind event as the bow continued eastward, going through I-44 and I-35. It took on that hurricane-like shape, feeding off those bands, giving it more inflow to produce damaging winds close to 100 miles per hour, and the couple tornadoes that did occur in the heavily populated areas of Oklahoma City. Now going into velocity data, out near just very close to El Reno, where that mesocyclone was, it started to widen out, and very clearly 60 to 70 mile per hour winds happened well to the south of El Reno. And then watch how it kind of evolves into a wider mesocyclone and merges with the storm to the south. And just prior of entering Cleveland and Oklahoma County, the winds did calm down for just a moment, producing 40 to 50 mile per hour winds. However, as it entered Cleveland and Oklahoma County, those brighter blues, and it transitions from the greens to the brighter blues and even dark blues, signifying 70 to 80 and even close to 90 mile per hour winds going across I-35. And this did hug just along I-40 as well, going eastbound. Those tornadoes particularly hung around I-40, go perfectly on I-40 actually, going east towards Shawnee. Now going into the eastern Oklahoma City area, the Bow Echo continued to produce tornadoes along I-40, and the final one occurred just northeast of Shawnee. It was preliminarily ranked EF1, and if you pay attention to just north of Shawnee here in just a moment, you can actually see the inflow notch and where those tornadoes obviously occurred, just north of I-40, and the damaging winds very much did continue. Let's go ahead and go into velocity here real quick. And obviously, again, these damaging winds really did continue on pretty much right over Shawnee, where constant 60, 70, and even 80 mile per hour winds continued, even out towards Highway 75 off to the east between Ocmulgee and McAllister. Now, I do think it was a well-forecasted event. However, I do feel like the Storm Prediction Center may have neglected a few of the models showing more supercellular mode rather than linear mode, because that same night, supercells outlasted the original timing we thought they would. However, there was one noticeable short-range model, the RRFS, which was showing a longer-lived supercellular mode. And these did eventually converge into that Bow Echo linear mode as they entered Oklahoma City like they were supposed to be. However, the Helicity tracks were still showing pretty strong conditions. And even the ACRRR model on the observed soundings were favoring a tornadic activity. So very, very clearly, the Storm Prediction Center probably should have put in there SIG 1 intensity across Oklahoma City, like central Oklahoma, as like a heightened tornado activity potential. And they did kind of mention the possibility for an enhanced tornado activity in some of their mesoscale discussions and tornado watch, or sorry, severe thunderstorm watch in the area.